All right, parallel lines and transversals. What in the world does this mean? Okay, so let's talk about this. Parallel lines, we know, so next year your definition of parallel lines is going to change. When you get into algebra, you're going to learn more about like the algebraic definition. But for now, parallel lines are what they've always been, the Romeo and Juliet of geometry. Parallel lines, they run next to each other. They're like right there, but they can never touch. They're always the same distance apart. Again, so tragic. But actually not tragic, because some good examples of parallel lines in real life, if you look at the hallways in your school, if you go to the very end of one of your halls and measure how far apart the teacher doors are, and then you go all the way to the other end and you measure how far apart the doors are there, they're going to be the same distance apart. Another one that's actually like a lifesaver is railroad tracks. So again, I'm not going to lie to you. I am not like some kind of like railroad track aficionado, but my understanding is that railroad tracks are universal because railroad trains are universal. So that means the wheels on a railroad track, like a rail car, they're the same distance apart. So the railroad tracks have to stay that same distance apart, because like think about it, like if you've ever like ridden roller skates, you're riding your roller skates and all of a sudden your feet go and then you fall, like your skates get all tangled together and you fall, or you go this way and then you do the splits and fall, right? You want your skates to go parallel. Same thing with a train. You want the rails on under a train to go the same direction, because otherwise everything gets all tangled. So they're parallel, they're never going to cross. That's what parallel means. I digress. But what we're talking about now is, again, we're thinking about railroad tracks, but now we're going to lay something over them. Now, we're not going to do that in real life because, like, I don't know, that seems dangerous. But think about like a street going across railroad tracks, right? So you have these railroad tracks and they're parallel forever because we don't want the train to derail and, tragedy. So this street is going across it. So the railroad tracks are the parallel lines and the street is the transversal, because it transverses, it goes across the parallel lines. Okay, so there's all kinds of interesting relationships that we see with these parallel lines and transversals. Okay, so we see that angles that correspond are equal. So what does correspond mean? Okay, corresponding means same place, different intersection. Okay? Vertical angles are across the corner, and they're also equal. Okay? And adjacent angles are next door, and they share a wall. So in my school, I am across the hall from Miss Singh, and I'm next door to Miss Schulteis. So like this is me right here. This is Miss Schulteis. Actually, hold on. This is me and this is Miss Schulteis, and that's Miss Singh. Miss Schulteis and I, we're adjacent because we share a wall. But Miss Singh and I have a hallway between us, so we are not adjacent because we don't share a wall. Okay? So, a better example of this, and again, this may not be a great example, but this is the example you get because I'm the math teacher you have. Okay? So I live in Houston, Texas. Well, I live in Cypress, Texas. All right? And this road that is by our school is called Little York. So this is Little York. And I don't know what that road is. I'm not going to lie to you. It's like movie theater road. I'm not sure, okay? So at this road, so our school is right here. This is my school. That is the craziest looking picture. That's my school. I don't know what is wrong. It's like a fun house, okay? So that's my school. Okay, so there's this major road called Highway 6. Okay? And there's like a bunch of restaurants over here. But right here, there's a gas station. There's a Skechers outlet, which is really weird. There's a CVS on the opposite corner, and there's a Houston Garden Center right here. Okay? Now, a little ways down the road, so there's like a movie theater right here. It's kind of awesome. There's all kinds of cool, there's good, they're not cool, but it's like Cane's, and I love that. And there's a barbecue place. And there's a Buffalo Wild Wings right here at this next major intersection, okay? Across the street from that, there's this weird old office building, and it's right next to the Casa Olay. And then there's a Captain D's, I think. It's like some kind of seafood fast food, and I don't know how I feel about that. And then over here is an Aldi. Why am I telling you this? Because understanding this is, like, for me, this is how I think about parallel lines cut by a transversal. So the parallel lines are like Movie Theater Road and Little York. And the transversal is Highway 6. Okay, so when I think about it, when we talk about corresponding angles, they're in the same place on a different intersection. So the Skechers outlet and the Buffalo Wild Wings are corresponding because they're in the same place, but they're on a different intersection, okay? The Skechers outlet and the Houston Garden Center, they're vertical from each other because I have to go across the corner. Like, I have to do some serious, like stunt person stuff. Like, I would literally have to get from the Skechers outlet directly to the Garden Center, Houston Garden Center, without going like normal people. If I like literally went diagonally, I'd have to cut across 7 lanes of screaming fast traffic. It would be so dangerous. We would all be in danger if I did that. All right. CVS and the gas station are vertical. Aldi and the office are vertical. Buffalo Wild Wings and the Captain D's are vertical. Okay. The office and the gas station, they correspond because they're in the same place on a different intersection. Okay. So when I'm thinking about corresponding angles, I'm thinking, okay, the Buffalo Wild Wings and the Skechers outlet, they're in the same place on different intersections. So when I look at this, these two angles are in the same place on different intersections. This is the Aldi and the CVS. Okay, they're in the same place, they correspond. Okay, when I think about vertical angles, I think about the Aldi and, is that right? I think about the Aldi and that weird office building. I think it's haunted. I don't know. The weird office building. Here's the Aldi. There's the haunted office building. Here, let's draw a ghost. Woo! Okay, there's my ghost. The haunted office building, all right? So this is the Aldi, and that's the haunted office building. They're vertical, and they're congruent. So maybe the Aldi's haunted. I don't know, all right? Now, we have adjacent angles, and they're next door, right? So the Aldi and the Buffalo Wild Wings are next door to each other. So these two angles are adjacent, just like the Aldi and the Buffalo Wild Wings, okay? I don't know if that helped, but that's how I think about this vocabulary, all right? So now, let's think about some other things that we need to know. So first of all, I can do something called match coding. I just made that up. So trademark, mega deal, all right? Match coding. And so what that is we're going to figure out which ones are the same, which ones are congruent, which ones are equal angle measurements by drawing something or highlighting them in some way. Now, I am a gigantic fan of the highlighter, but my students will not get down with my highlighter game. So this time I'm trying something different. I'm not happy about it, but I'm doing it because I'm trying to go where the children are. I'm trying to be hip with the young kids. So here's what I do. I'm going to draw a cloud on this first angle I see. And you notice how I kind of turned it like this? Because I always do it in the same pattern. So like here, I would do it like this. And this one in the back here, I would start here. I would start here. I would start there. Okay, I always start kind of at the first angle, the top left angle I see. And then I draw the guy across the corner gets the same shape. I like clouds, they make me happy. Okay, the guy that's corresponding, so the guy that's on the same place but at the other intersection, he also gets that same shape. And then the one across the corner from him does. So basically the Aldi, the haunted office, the CVS, and the gas station, they all have the same shape. Now I'm going to do a different shape. Originally I was doing circles and rectangles, but like honestly they all started to look the same. So I'm doing clouds and let's do clouds and hearts. And let's do clouds and triangles because they're straight lines. So then all the other ones are going to get triangles. Okay? Why did I do this? Because clouds equal clouds, and triangles equal triangles, and a cloud plus a triangle equals 180 degrees. What does this mean? This means anywhere I see a cloud, I can put an 83. I mean, not always, but just because this one's an 83, okay? And it means 83 plus something equals 180. So if I want to find out what that is, I just say 180 minus 83, and then I let my calculator do its magic. 180 minus 83 is 97. So that means that the triangle is 97, which means that every triangle is 97. So just knowing one angle, I was able to find all 8 of them. And by match coding these, and you don't have to use clouds and triangles if you don't want to. I don't know what's wrong with you if you don't, but you know, that's your thing, it's your jam, you do you. If you want to do circles and squares, if you want to do like, you know, I don't know, if you want to draw an elaborate panda, I don't know what your thing is, you do you. But pick a shape, you're going to do the angle, and so that shape goes vertical, this one and its vertical angle, and then the 2 that correspond, meaning the 2 that are in the same place on the other intersection. And then cloud equals cloud, triangle is triangle, add them together to get 180. Okay, so let's try it. Let's try it on some of these back here. Okay, so step 1, I match. Okay, I match code them. Okay, so I start with my clouds because you know that makes me happy. Okay, and then so I did the angle and its opposite, and then it's the 2 that correspond. Now I'm going to put triangles because that's how I roll. Now, I have a 1 here. So they're telling me they want to know what angle 1 is. So literally, I'm going to say, I'm going to write equals cloud, triangle equal, I'm sorry, it's been a long night, equals triangle, cloud plus triangle equals 180. Well, I know about this one. So I know that everything here is 120. Am I looking for a cloud? No, because my 1 is in a triangle. So I need to say 180 minus 120. That's 60, right? I don't know. I got to check my calculator. It's been a long day. It's 60. So that means, that means anywhere else I can put a 60, so angle 1 is 60, and that's what my answer is. All right, let's try another one. Okay, this one. I have cloud, across the corners a cloud, same place on the other intersections also a cloud. Triangles everywhere else. Oh, look at that, my 1's in a triangle again. Did I do this? I'm going to move this one. I don't want to talk about it. Okay, all right. And hold on a second. I'm going to just give me a second. Fine. Okay. So let's look at this. So I know that my cloud equals cloud, triangle equals triangle. And again, I'm writing this because you know what shapes you're doing. Like you got to, whatever shapes you do. So triangle plus cloud equals 180. Well, I know that cloud is 40. 180 minus 40 is 140. So triangle is 140. Angle 1 is a triangle, so it's 140. And honestly, half the time I actually draw the triangle on the question, so I make sure that I'm picking the right shape. Okay, so let's look at this one. This one time they gave me, meaning I, gave you 2 numbers. I gave you 1 and a 2, and I'm asking you to find 2. So we're going to start by doing our match coding, right? So we do cloud, across the streets, across the corners cloud, same place in the other intersection, and across the street from it. Triangle, 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 okay? Okay, so I know cloud equals cloud, and triangle, what shape is 2? 2 is a triangle. I already know what triangle is. Triangle is 60. That means angle 2 is 60 degrees. I don't even have to do any math on this one, as long as I label these so that I can tell where they go. All right? If you have any questions, let me know. That's not what I meant.